Hi everyone. I hope you hear me well. Let's check the sound. Please send us where are you from which part of Spain or other part of the world, so we can check that you hear us well. Okay, I don't see any comments. There could be two reasons: you're too shy or you don't hear us. Poland, hey Alexander. Okay, let's then start. While we are waiting a couple of minutes for other people to join, I want to steal just a couple of minutes and tell you just a little bit about EPAM, because actually employees of EPAM are going to share their knowledge and experience today. And probably you just haven't heard about EPAM before. So EPAM started as a company of 3 people almost 30 years ago. And that was a long way, full of ups and downs for sure. But here we are in 2021, having almost 60,000 people. And I guess the real recognition is that EPAM was included in S&P 500 and Forbes Global 2000 last year. So this is like really incredible. And we are presented in 45 countries around the world. And I believe we have clients even from more countries. And who we are? I like to think of us as a group of people who like to create tech products. So we are different, we play in different roles, but the final goal is to create the product to address some business problems, some business needs, and so on. And talking about EPAM in Spain, it is a very young office. We started just like 3 years ago, but now we have almost 1,000 people here. Originally, the idea of Spain office was to attract the most talented people, so we invited them all over the world. And now we have 45 nationalities in our office. And if you like working from office, good news, EPAM has office in a great location. It's near to the sea, it's not so far from the Malaga center, so this is really like cool place to work. And just finish the presentation with some positive vibe. I want to show you a short list of EPAM awards. For sure, the important thing here is not award, but the fact that third-party companies evaluate our work so high. So I'm proud to work in such company as EPAM. That's it from my side. I guess here we have people more interested in data. So here just the QR code on EPAM data department page. So probably you can know more about us and find something useful for you. Yeah. And I guess we can start. The next person, actually not person, but team who will be presenting is Luka and Denis. Hi, guys.
Hello, Kseniia. Thanks for the introduction.
Yeah, you're welcome. The floor is yours.
Okay.
We're going to listen for a very interesting story about how to become a data scientist. Wow.
Thank you, Kseniia. Hi to everybody. My name is Luka, and today I'll be sharing the story of how to become Data scientist. I recently finished the EPAM's data science mentorship program, so I would like to share some things and hopefully pique your curiosity. So, how to become a data scientist? Well, let's say a few things about me first, and then I'll jump into the subject. I graduated psychology. I have almost 6 years of working with data in various forms. I started as a data analyst. I moved a bit to data engineering and worked a bit as a back-end engineering, all in Python. I recruited participants for certain projects. I created ETLs, dashboards, etc. So, for better or worse, I can say that my experience is pretty dispersed. So, now I want to say something about data science situation in EPAM specifically. So, we have around 300 data scientists spread across 22 countries. When you join EPAM as a data scientist, you can have two options of progressing. So you can either go in depth, starting with junior, like me, moving to mid-year, senior, lead, etc. Or it might interest you to go horizontally. For example, you're a data scientist and you want to be data consultant and you want to be a delivery manager. It is possible. And there are multiple domains you can land yourself in, whatever interests you, the usual natural language processing, computer vision, recommender systems, MLOps, time series, etc. So, how do you become a data scientist? Well, I would like to say I don't know, but the real answer is it depends. And by the way, it depends is an answer that works well on most of data science questions. So I just want to say what I'm not going to be talking about today. I'm not going to be talking about the usual roadmap of a data scientist because I think that on the internet you can find a lot of these articles. I know that I've found a lot of different suggestions, different fundamentals, different ways how you can achieve this. So is it math, to statistics, to entering scores on Coursera, or then later to Kaggle? Well, I'll leave that to you. What I want to talk about today is what EPAM mentorship course has to offer that I think will boost additionally. We don't ignore knowledge resources, but we offer some other couple of things I'll be talking about today that it's very rare to find in the industry currently. And if you're not thinking, okay, but why should I be interested in hearing this, watching this? Well, good news is you can and you should apply. Everybody can apply. So without further ado, let's jump into it. Okay, but I would like to say a few about the parts, a few words about the parts of the course. So there's traditional approach, learning from the book, and then testing. The same thing is here. So theory, input learning, absorbing, reading materials, watching videos. That's what we all know how to do. We try to absorb as much as we can, but maybe and especially in the world of data science where scope is quite big, there's a maybe not a need to learn everything. For example, if you want to be an MLOps engineer, maybe that math is not for you. But anyways, the point is on input learning. You have tests, of course, and apart from tests being there to test your knowledge, of course, there is multiple other benefits to test, like looking your weak points or maybe solidifying your knowledge through repetitions. But the test, therefore, it's your traditional purpose. But there's another thing that I think is, and at least for me, it was a very useful, if not the most useful, is practical assignments. For every module, which I'll be talking about later, you get an assignment. So a lot of things in data science is not just learning and testing, it's actually coding, visualizing, making mistakes, troubleshooting, going on Stack Overflow, and troubleshooting more. So a lot of things have to pass through the fingers, how to say. Did they mention troubleshooting? Anyways, I think this was completely useful for me, and especially, for example, if you learn a module and you learn how to do a homework through, let's say, coding assignment, and then let's pick exploratory data analysis, and you finish that assignment. For the next one, well, in lots of data sets, if not in all, well, you need to do some data analysis work, exploratory. You need to do some visualizing. So in every subsequent module, you will need to do exploratory data analysis. So every module builds upon each one, and everything passes through your fingers. You code everything out, and it's basically a mini project. So I said this is a very valuable thing that we offer in the course. But there's another one, and that's having a mentor. So I remember when I was self-learning, and I did it a lot, I was always finding information about and recommendations about how important it is having a mentor. And I was always thinking, okay, but where will I find a mentor? Where should I go looking for one? Why that person wants even to be my mentor if it's for free, but mostly on the internet it's not for free. So I was pretty much discouraged. But actually here is not that situation. And if you remember my point about being a data scientist and test and theory and learning and how it's in input learning, well, output learning has its own benefits as well. And output learning is teaching somebody. So both sides, both mentee and the mentor, get something from this. And I know for sure that I will also be applying to be a mentor for the next person. Okay, I mentioned there are certain modules, and on this slide you can see all the modules that are being worked in this course. So from exploratory data analysis to basic statistics, etc. My favorite one was unsupervised learning. And for people that don't know, there are certain schools like splits in machine learning, supervised learning, unsupervised learning, reinforcement. And while supervised learning is monitoring the algorithm, providing inputs, controlling the outputs, measuring it. Unsupervised learning doesn't have that. It doesn't have neat metrics like classification. It's basically a black box. You input some data and you get something. And I was first very frustrated, like, okay, what am I going to do with this? But then you start thinking about this much more curious way. And unsupervised learning is basically asking the math, hey, what do you think about this problem? And then the computer answers you. And this the picture is what computer answered me on seismic activity data. I'm still not sure what it means, but at least it might be another perspective to think about. Okay, so what are the consequences, the outcomes of this course? So there are two, at least I see two. So there's personal growth, and this is very much true. You start a journey, navigating through data, completing projects, trying to, like I mentioned, troubleshoot, finding answers. So it's not quite easy. And first of all, you have to learn how to handle all these problems. So it's a bit softer knowledge. You learn how to plan your project out. You need to learn where to find the necessary resources. And I'll guarantee you, what you find on the internet, on the first link, maybe it won't work on your computer. I know for me, it did not. So there are a lot of uncapped libraries. So you learn how to handle this. But also you learn more about the data science itself. So yeah, you become a stronger data professional, whatever mentorship program you choose or opt for, whatever you're interested in, but you come in as with a strong body of knowledge and learn how to handle all that knowledge and how to move forward. And that happened to me. So I learned a bit. But what I want to say is really important for me, or was like a personal growth, was now I know how to transfer the data science jungle body of knowledge, and I know how to and where to go, at least start. But besides personal growth, there's also concrete benefits. For example, all people that finish the course, apply and finish the course, can do an assessment of your knowledge. If you pass the assessment, well, you officially can be offered a position as a junior data scientist. I was already in EPAM when I applied for the course, so I was not getting a job, but I got a horizontal movement. And luckily, I'm here. So, personal growth never stops. And for me, there's also a lot of opportunities to going further in your knowledge. And luckily, EPAM offers that as well. So this is a data science basic course, and I continue my specialization in MLOps because I want to work on my engineering skills. And I got a new mentor, and I just started working. So I'm again a student, and like I mentioned, personal growth never stops. But before we finish, I'd like to maybe share a more personal side to this story. So, like I mentioned, I graduated in psychology, and I was always asked by people, "Hey, what are you doing from social science and data science?" And I would like to tell to those people, for those that don't know, maybe some do know, but there's a lot of common. There's a lot of experiments, research, a lot of methodology, and there's need to be something that needs to bind them. And psychology offered statistics. Through statistics, I encountered SPSS, a software for doing analysis, but I did not like it that much, so I tried learning from the R programming language. Through R, I got in touch with coding. Through coding, I got in touch with Python, and I just started coding more because I really enjoyed it. And before I continue, I would like just to add that Frank Rosenblatt, sometimes called the father of deep learning, the person that invented the perceptron, was actually a psychologist. So, yeah, okay. So fast forward to EPAM. I got offered this program to participate in this program, and at first I was thinking, okay, maybe this is like LinkedIn Learning, and I have nothing against LinkedIn Learning, but that was usual what was offered in companies. But soon enough, I met my mentor, we chatted. I was relieved to understand that we both have similar goals, or if not the same, and that's learning. And I could maybe continue with less, more free, more interested, because we're both getting some out of it. So I started doing the assignments, started learning, and until the first assignment, it was a breeze. And then, until it wasn't. I faced a lot of issues. I was having troubles a lot through as you can see on the slide, it's the famous Dunning-Kruger effect, the axis of accompanience and confidence. And until first assignments, there's a bit of hand-holding, and then you need to do your assignment. But you can't do it that easily. And I was told before I started this course, that a lot of assignments are very hard, and a lot of people drop out. And I understood why. I got very demotivated. And on top of that, I relocated to Spain. I was now in a beautiful country, living near the sea. And once I finished my work, then I had to stay working. And instead of swimming, I was working. But I got angry. I wanted to not to drop out, not to be another casualty. And I started moving. And luckily enough, soon after foundational blocks were finished, fun things about machine learning started popping out, and I got wind in my sails again. As soon as I got to the end, I was very rushing to finish the course, and I did. But looking back, I think I'm glad that I did it, but I sacrificed too much of the time. And a lot of people, including me, agree that this is a marathon and not a sprint. So, I finished the course. Congratulations to me. Can I call myself a data scientist now because I finished the course? Can I call myself a data scientist because I know a bit more about machine learning algorithms? I still don't know the answer to this question, but I know that I learned something. And for me, that's enough, because now I know where to go, and I know how to get some knowledge and how to build upon it. And it's a strong foundation. So personal growth never stops. And I said I will have some stories. There's one more story. And this story will not be told by me. It will be told by my colleague, Denis. So without further ado, let me introduce you to my colleague, Denis.
Thank you, Luka. Hello, everybody. Yes, I'm Denis, and I'm data scientist from EPAM, and I will add my stories to the picture painted by Luka. Luka told us about his horizontal way to data science, how he changed the profession inside EPAM. I went the other, vertical way. I was neither data scientist nor did I work in EPAM, and I went through the same course but in another manner. I'm starting with answer to two questions that were very important to me. The first question, why data science? Because I already was a scientist, though not data but a physicist, and because data science is a science and art of how to extract dependencies from data and use them. For me, the theme was interesting and the transition seems to be natural. The second question, why EPAM? When I started to look around for my new opportunities, fortunately, that was the time when EPAM started to organize a data science meetup in my city. And I attended the first meetup and the second one. And during to the third, I understood that that is a field of activity where I would like to work. And I realized that these are people whom I would like to work and communicate with. And uh, for me, it was very important that you can not only work in EPAM but also grow there. And now let's dive into the story of my pains and gains due my education. Well, one summer day, an announcement from EPAM burst into my view. It said that the data science course would start soon, and those who perform well would be invited for an internship, or they could even get a job offer. And I started my journey. This journey was full of discoveries, of course, and it lasted 4 months. And frankly speaking, for me, the scheduled course with a group of students suits me better than the mentoring case depicted by Luka, since I can keep a pace. Totally, I spent approximately 300 hours for studying. From a life point of view, it means 4 evening for theory and whole weekend for the practice. It was not an easy ride, but it was worth it. The result of my effort was a job offer, but I also gained some other very important things: knowledge, experience, insights, and of course, friends. The drawbacks were I forgot how to sleep 4 hours a day, and I grew a haircut in Bob Marley style, and got red vampire eyes. Only a year has passed since I started studying the course, and I was there again, but already as a lecturer for external students like me who desired to enter EPAM, as I was invited to talk about time series. Time series is a part of data science dealing with data which are dependent on time, from forecasting of sales up to earthquake predictions. And as a lecturer, I considered my purpose as to provide basic knowledge and give basic skills of time series as many and as good as I can during 3 hours. Though the teaching time was only 3 hours, the preparation for these two football games took 3 months. And here I understood with all clarity how good the lecturers that we had were. While I was preparing the lecture, I lost my self confidence, but gained knowledge and insights. And thanks to my colleagues who were so kind that they even convinced themselves that they understand something about this subject. And even this transformation from student to lecturer is not my happy end. And here is my next chapter, mentoring. Luca told us about his experience, his feelings as a mentee during his horizontal movement inside EPAM, and I'll open a door to the kitchen of mentoring for a while. The key difference in the roles of mentor and lecturer is that a lecturer should talk about only one topic in 3 hours, while a mentor should provide answers and knowledge about the entire part of data science that a mentee can touch on. Though the mainstream, of course, is still the basic EPAM data science course. Usually it takes about 6, 8 months. It depends on the pace of mentee. The advantage of an internal mentoring program in comparison to the standard one is one-to-one collaboration, an opportunity to ask about anything and moving at your own pace. Just a second, please. And on the contrary, when you go through the standard external program, you have a strict schedule and you have fixed finishing points, and you have an opportunity to ask your question not to the one person but to the different prof. And as mentor, yes, I refined my knowledge, but that was a time when I came close to enlightenment, since I should study to life here and now, because you never predict what these damned mentee ask you. And in my last slide, I dare to formulate some bullets about entry point to data science, what is preferable to have in front of the door. The comparison of 3 different data science schools where I happen to study tells me that EPAM data science course is the best option. It's compact, it's swift, with a huge amount of knowledge, hands-on experience, and multiple and valuable feedbacks from professionals. Of course, this statement is based on only my experience, and I should mention that those 2 other schools were pretty strong. It will be good if you have a background in Python, basic knowledge of math, like calculus, linear algebra, probabilities, and statistics. All these things I appreciate it. But to finalize my story, I would like with 2 short statements. Indeed, the most necessary things that you should have for success are goodwill and great desire. And yes, it will not be an easy ride, but as for me at least, it is worth it. And that's all from my side. Thank you.
Thank you. I just can I hear anything?
And now? Okay,
Yeah,
I'm sorry.
now works.
Okay, we already have some questions in the chat, and let's wait for more ones. I will start from the first. Do you need to have some math background or to be PhD student already have PhD to become a data scientist?
Dennis, I believe this is in your...
Yes, let me step in with the answer. No, PhD is not a necessary thing. Of course, if you have some professional knowledge in mathematics, it helps you. But indeed, pretty similar basic course of math on the bachelor level. I think it's definitely enough, and even without this knowledge, you can pick some necessary pieces of knowledge, like basic calculus about derivatives, integration, about some fundamental from theory of probabilities. You can You can find this basic knowledge even if you haven't a bachelor degree. That is the
Okay.
answer.
Thank you, Denis. The next question, Luka, it's for you. So how much time did it take to pass the course?
Okay. For me, it took 6 months. I think I was maybe 2 weeks before. But like I mentioned, it's very hard to keep a constant rate because a lot of things happen in your life. And as did mine, I had some periods where I could work more and some periods where I could do work less. But I also want to say that it's not only how external reasons affect your workload. Well, it might be that you're sometimes lazy, demotivated. Well, you're just a human, right? So for me, it was 6 months, but I had some really ups and downs. But yeah.
Thank you. And Denis, I think you mentioned that it was 4 months program, right, for you?
Yes, as far as I remember, we started in August and finished in November. August, September, October, November. Sorry, I'm data scientist. I should use fingers. Yes, 4 months.
Okay, great. Thank you. Denis, could you answer if data scientist has to write code or it's only fingers and math?
You should know how to write code. You should know the math since nobody knows which problem you faced with. As for me, I'm in EPAM for 1 year and 4 months. I work within 3 projects, and one of them was the project where I should write code. But the current project is more about math, but well, even you have some calculation in math, you can take these papers with these formulas and try to put it in the computer just to provide the numerical answer. That's why, once again, you should write the code. But maybe the second mention my answer in contrast to the first, yes, you should write the code. It's pretty easy to write code. You can start with an easy code and, well, okay, we'll teach you write more complicated. It's not so... Don't worry about it.
Okay, as soon as you finish the data science course, you shouldn't worry about anything.
Oh, yes.
Okay.
Only about my haircut.
Yes, right. Actually, people says that they love Bob Marley hair dress style. So yeah. Yeah, we have just time for one more question. Luka, it's for you. We actually didn't say who is data scientist because it's now a buzzword. So could you please just give some examples? What could actually do data scientist?
Okay, so yeah, this question is very popular, and one of the main reasons why I don't like going to the data science conferences because there's at least 2-3, I think, lectures that try to delve into this, and of course Python versus R. And I don't want to be that presumptuous to say, this is who is data scientist, but for me, I think this is a really broad role. So if you have a data science problem, and if you do it, if you have a data problem, it's your job. So basically, you have a palette of tools that you can choose. And it doesn't matter what the problem is. If the problem requires for you to do machine learning, great. If it requires to do deep learning, even better. If it requires you to do some visualizations for this certain project, well, you will do it. Why? Because you're a data scientist, right? So you should have just a broad spectrum of tools. And that's, I think, who the data scientist is. The type of work doesn't define you. So, and for my current project, I started as a maybe potential machine learning problem, but it then shrinked to some math and some, let's say, well, I don't know, use of that math. So, I mean, less of the design. Well, no, it's just still in your playhouse. So every type of problem, if it's data problem, I think it makes you a data scientist. It depends how you approach it. So that's what I personally think.
Okay, thanks a lot. Thanks a lot, guys, for your presentation. I hope now everybody knows how to find this path to data science if they want to.
Thank you, Kseniia.
And yeah, goodbye. The next topic will be about bias in artificial intelligence. Hi, Antonio.
Hi guys, how are you? Hi Kseniia. So let me share my screen. Okay.
Yeah, now we can see it. Yeah, good luck.
Okay, perfect. So thank you all for staying here today. And now we are gonna handle a topic that is not commonly discussed of AI bias. And yes, some of the challenges and some real cases that have happened and in which bias has a very strong impact on society actually. So a few words about myself. I'm senior data scientist at EPAM, and my main research interests are computer vision, natural language processing, and mathematical optimization as well. So yeah, as I mentioned, we're going to go through a bit of an introduction, now some real cases, and then what can we do to avoid bias as much as possible in our everyday life and in our projects. So what is bias? Bias is basically something we cannot avoid because every one of us is impregnated in bias. Because if we, for example, think of a physician, it's most likely that we unfortunately think of a man rather than a woman. And if someone asks us to give the expected gender of a nurse, we say a woman instead of a man. But that is because just of a brain efficiency in the way that since many of the samples that we've seen in real life are according to that specification, our brain automatically make that inference to make our life easier and in order not to retain all the information that we've had in the past. So that kind of human bias can obviously be transferred to machines via data labeling, because as you know, especially in deep learning setups, data labeling is really, really important. And we have images being labeled constantly, text being labeled constantly, entities being labeled constantly, and so on and so forth, even audios. So that human bias is very hard to avoid, the fact that it goes through and propagates to the data, and therefore machines can also be infected in a way. So technically, how can artificial intelligence bias be defined as an anomaly in the output of a machine learning algorithm due to the prejudiced assumptions made during the algorithm development process or prejudices in the training data? So yeah, as I mentioned before, we can find two main reasons for us to detect an AI system with a bias. One of them is the cognitive one, which are the unconscious behaviors that we have in our everyday lives, and we propagate those decisions to the data. And also lack of complete data, because there a lot of times happens that we do not take into account a specific variable, and it turns out that it's quite important. For example, as you can see here, in the inequality and discrimination in the design of use of AI in healthcare applications, you can see these four main groups, so to say, with real-world patterns of health inequality and discrimination, discriminatory data. For example, taking into account the gender of a person or the race of a person can lead to a strong bias in our models, but also it can be helpful in another circumstances. So we need to really be aware of how we handle that information. And also injustices, which we're going to go through some of them right now. So basically, what are the challenges towards AI bias is that during these last years, especially with the development of transformers technology since 2017, there's been a huge movement inside computer science of democratization of artificial intelligence, which on the one hand is obviously pretty good because that makes technology and the state of the art accessible for everyone. But freedom always comes at a cost, and that means that everyone can have access to those technologies and they cannot make the most appropriate usage of those technologies. So as you can see here, obviously Hugging Face and Fast AI have made an enormous contribution to the world of artificial intelligence, but also some people can take benefit of that to make like low quality models and low quality production solutions, which is what we're going to see right now. So yeah, first case, Amazon. They decided in 2014 to develop an AI-assisted hiring process. And what they did is that they took a broad range of historical data through all the previous interviews that were obviously handled by humans. And what they found out is that the gender was having a really strong impact on the model decisions. And the reason behind is that for technical roles, the proportion of male is significantly higher than the proportion of female. So people in that team didn't take into account that variable. They took it as just one more variable, I suppose, inside the data. And it turned out that it had quite a lot of impact in the production model. And this solution was obviously removed. Okay, so the second use case belongs to Facebook. Now it's Meta, but it refers to the social network, so it's still correct. So in this case, in 2019, Facebook was allowing its advertisers, because you can pay to put your own ads in Facebook, if you didn't know that, and you could specifically filter or more precisely target some specific groups of population based on gender, race, religion, but also hobbies and so on. So that obviously led to a huge bias, and this is not like an unintentional or machine bias. This is a bias that you are allowing to happen because you are giving the people who pay for the advertisements the chance to target people, and that was obviously having a really strong impact on the user experience. So as you can see here, Nebraska Furniture Mart family was a piece of advertisement directed strictly for male, and also for the need work today advertisement on the right side of the image, you can see 4 pictures, all of them associated to male. So this advertisement was also targeted for male, and you could also see another advertisement from the same sponsor with different images, all of them related to women doing different jobs in which women are more represented. And that advertisement was targeted for women. So obviously there's a huge discrimination in that conduct. So yeah, this is obviously something that got out of the Facebook services afterwards. Third one is the CCTV surveillance, and this is a pretty interesting one because you can see a documentary on Netflix called Coded Bias, which is what you can see here. So at the beginning of the millennia, in there was a CCTV system with headquarters in Beijing, and the intention or the purpose of this system was to identify, for example, like suspicious behaviors, like one is going to kill someone or commit a robbery or something like that. But at the end of the day, the CCTV system was able to collect and to gather so much information, like daily routines, common patterns, like if you prefer coffee, if you prefer tea, whatever, everything. They could know everything about you. So that tool that was intended not to be obviously harmful for people turned out to be like a system of propaganda, and that is obviously really, really discriminative, because it can end up, for example, targeting as a potential criminal to someone from a specific race, which is obviously not a bad behavior. It's an awful behavior from a machine. So yeah, this is also a quite a criticized application of artificial intelligence, and that it should be conducted and fixed. And yeah, what can we do in order to avoid this kind of let's say biases in computer vision? We can make usage of synthetic data sets, which are quite popular in the state of the art, not only for image classification, but also for a certain amount of tasks like image segmentation, pose detection, as you can see below, even depth estimation and image retrieval, like the gestures of the face and so on and so forth. So yeah, I highly recommend you to go through these two data sets, the one above and the one below, to see how they can have a very positive impact on AI towards bias. And there is one last example that I really like, because it is very, very recent. It was published in 2022, and it's about Neutral. Neutral, for those who don't know, that company is a fact-checking startup that has started using AI to solve some kind of fact-checking and to kind of follow these fake news and so on. So what they did for the first experiment was to take tweets from politicians to measure the toxicity. So there are a lot of questions that someone can make, but obviously the first one is the time window that you choose. Because as you know, obviously, if you're going to measure the toxicity of politicians, you need to take into account that obviously if there is one party ruling the country at a specific moment, the political party with the opposite ideology is going to be more critic and more toxic toward the government, because they don't share the same ideas, and the other way around, obviously. So they took it from tweets. So Twitter was founded in 2007, if I'm not mistaken, but became really popular around 2010, 2011. So this could be the potential time window that they could have chosen, like 10 years data, which could be a good one, taking into account that there were, let's say, government from different political parties, which is also good in order not to bias the model. But they chose this data time window, just 2021, which, as you know, was the government in that time is the let's say the red one. Okay, so it's not hard to imagine that if we build a sentiment analysis model towards toxicity with only data in which the government has been represented by a specific political party, the other parties are going to result in a higher average toxicity. Okay, so that's not, you don't need to build a machine learning model for that. You can imagine it. Okay. So obviously you can make your own conclusions, and you see that the political party that was ruling last year and is ruling at the moment has the smallest average toxicity. That is not hard to imagine again. And this is also a political party that is ruling at the moment. So obviously is the second small average toxicity. And these are the other political parties, which obviously lead into a higher average toxicity. So yeah, again, this is obviously a mistake, and this is a model that it's already in production. So this is really a problem, and this is a model that, as you could see here, has been open sourced in Hugging Face. So if someone comes here and makes use of this application, they're going to get really bad results. And it's very important for you that whenever you see something, you are critical about that and you say, okay, has this been properly trained? Are the people behind this company experts? And are they good enough doing these models and elaborating these techniques? Because obviously in this case, it's not. So yeah, how to avoid it? Just basically be aware that in every machine learning or deep learning or data science problem, that it could be a bias. So at the very beginning of the project, just make sure that what could be the potential risks for AI biases. Try to keep good practices around through all the development of your proof of concept, of the development on when the model is going into production. Also engage with different sort of experts in the field, and also try to get some different direct feedback from consumers. And it's also very important to get strong collaboration with multidisciplinary teams to get the best results in this sense. So yeah, this was all from my side. I'm happy to hear your questions.
Thank you. Thank you so much. Well, let's start from some questions from the chat. How to detect bias? And classical scores of the model will be lower if you exclude such a bias from the data. Are there any specific metrics?
Yeah, that's indeed a good question. And yeah, it depends a lot on the data that you're using. There is actually not like a unified criteria for avoiding bias. Because, for example, if as I try to put some use cases with different data domains. For example, if you're using images, it's obviously true that you need to check the ethnicity of people, the gender, some kind of variables that can lead to some bias. But also, if you're using images from like outdoor scenarios, you have also to check the weather conditions, for instance, because if you take all of your images from a sunny day, the model is going to have a good performance at night or when it's a windy or rainy or foggy day. Okay, so bias is not only for like kind of gender or race discrimination, but it's also for kind of environment conditions in general. And yeah, also if you're using text, what I can recommend is to have like an entity recognition patterns to look for some kind of common expressions and so on.
Mm-hmm. Thank you for your answer. Actually, we have a related question. Is it like a problem of data quality or data science, or what do you think?
Yeah, absolutely. And I think indeed that we spend over 80% of our time handling with data. And when I mean handling data, we mean taking a look at the data, exploring data, manipulating data, pre-processing data. At the end of the day, getting data ready to be consumed by a model. And even if in deep learning we don't do such a profound pre-processing steps, but we need to be aware for that same reason, we need to be aware that all of those conditions that I mentioned before, for example, when dealing with images, the weather conditions, it's obviously like luminosity, blur, everything related to images. You need to be aware that that could happen in a production environment, for instance, and you need to be aware of that. So definitely data cleaning and data preprocessing takes like most of the time in a project, in real projects.
And I'm not sure if it's related to the topic of your presentation, but how do you think if it's okay that after buying a bet somewhere, I still receive ads for bets that I don't need anymore?
So I didn't get that question.
So the person asks if it's okay that after buying a bet, he still receives the ad of bets, but he doesn't need it anymore.
Yeah, so that is not strictly related to the talk, but yeah, obviously advertisement have I'm gonna put the slide of the ads. So yeah, advertisements are fed from a lot of cookies and a lot of metadata that is stored in web pages. So yeah, obviously they make a very aggressive usage of that data, and that I think is going to be regulated from next year. So I know for certain there are some companies working on developing some kind of contextual advertisements, because that's something that is quite obvious when you go, for example, to a sports web page and you see advertisements for about trips, about going to New York, for instance. So that is obvious. It doesn't make any sense because it's not related to the context of the web page. So I know there are some startups working on those kind of contextual solutions using artificial intelligence. So yeah.
Thank you. And the last question, is it possible to recognize any face of any nationality or race? That's a tricky one.
Yeah, I mean, nationality obviously is not that easy because now we live in a globalized world, and there are, fortunately, you can find people from all walks of life in every country. So yeah, for example, you can see Kseniia being in Spain, but it's not actually from Spain. So obviously that can lead you to have some, let's say, it's quite difficult to. But I think what it could be easier is to predict the ethnicity, because there are some kind of specific facial patterns and facial gestures that can help you discriminate that way. Yeah, and I think there are some intelligences prepared for that, but yeah.
Okay, thanks a lot. We are out of questions and out of time. So yeah, let's move on. Hi, Jonathan.
Hello.
Yeah, Jonathan will present today in Spanish. So they're going to have a chance to listen for a nice language here.
Okay. I'm going to share my screen. Let's switch the screen. I'm going to switch my language as well.
Good luck.
Ok, vamos a hablar de análisis de sentimiento y ruido. Mi nombre es Jonathan Espinosa, soy científico de datos. Yo empecé mi carrera al igual que Luka, digamos que no exactamente como ingeniero como científico de datos, empecé más por el lado de desarrollo de hardware y me dedicaba básicamente al análisis de señales en temas de telecomunicaciones. Hace unos 3 años me moví a la parte de ciencia de datos, desarrollando sistemas para segmentación de usuarios y NLP básicamente. Y hace un par de años, pues empecé mis estudios de doctorado, donde investigo en temas relacionados con minería de opiniones y temas relacionados sobre cómo representar esas opiniones, esos sentimientos, ¿no? De manera fácil de entender. El día de hoy, pues vamos a cubrir 3 tópicos. Vamos primero a ver una introducción sobre qué es el análisis de sentimientos. La segunda parte donde nos vamos a enfocar mucho es sobre las formas en cómo se anotan esos datos, ¿vale? Cómo se crean esas etiquetas para determinar si un grupo de datos tiene determinados sentimientos, polaridades o emociones. Vamos a entender cómo el proceso detrás que hay de esto. Y finalmente vamos a analizar los tipos de ruido que existen y cómo podemos mitigarlos. Perfecto. Pues primero, pues tenemos que definir qué son emociones y sentimientos. Se refieren básicamente a esos estados de ánimo o disposiciones emocionales hacia una cosa, un hecho o una persona. Definen muy bien cómo vemos el entorno y cómo reaccionamos hacia él, ¿no? Desde una perspectiva psicológica, subjetiva. Si analizamos las tareas de clasificación de sentimientos, pues las definimos como todos esos enfoques que nos permiten automáticamente extraer, clasificar o evaluar emociones. Para poder entender los tipos de datos que tenemos, pues tenemos que analizar los tipos de enfoques de cómo usamos esas fuentes de datos. La más conocida de todas es el texto, ¿vale? Donde lo que hacemos generalmente es identificar los segmentos de opinión dentro del texto para poder dar una evaluación, qué emociones o qué polaridad tienen esos segmentos de texto. Pero también no solamente se explota el texto, también se explotan las imágenes, donde los enfoques más populares se basan principalmente en expresiones en el rostro y también en lenguaje no verbal. Pues el lenguaje no verbal define mucho sobre nuestras emociones y nuestros estados de ánimo. Otro de los componentes que también se han experimentado son sonido. Típicamente se extraen unos features de la voz y con esto pues se utiliza un clasificador para utilizar estos features y determinar diferentes estados de ánimos. Por ejemplo, para detectar estrés o ansiedad. Son dos casos de aplicación muy populares. Y las señales biológicas en las que tenemos un poco de todo. Sistemas que miden nuestra piel, el movimiento de nuestras pupilas, señales con electrodos en nuestro cráneo, señales de nuestro corazón, nuestra respiración, etcétera. Aquí algo que tenemos que considerar también es el dominio, de dónde vienen esos datos. Pues si van a buscar bases de datos en Internet de análisis de sentimientos, pues van a encontrar que son de dominios de aplicación muy específicos. Unos vienen de política, como los ejemplos que mostró Antonio hace un rato, otros vienen más de redes sociales, otros vienen más de comercio electrónico, hotel, restauración, etcétera. La forma en cómo se genera estas bases de datos, pues tenemos tres formas principales. La primera son actuados, en la que hay un guión y se contrata a un grupo de actores para que simulen esas emociones. Algo bueno que tiene es que vas a tener todos los datos que quieras y balanceados en la forma que quieres, porque puedes decirle a esos actores que repitan las escenas que quieres describir para representar esas emociones que quieres mostrar. Pero claro, tienes digamos, una ausencia de naturalidad en esas emociones, ¿no? Que es muy importante. La segunda es datos evocados. Básicamente se induce a las personas a ciertos estados para tratar de simular ciertos estados y emociones. Un ejemplo de esto, típicamente lo que se hace es poner a las personas a ver algunos videos, escuchar ciertos sonidos para tratar de evocar esos estados y luego, después de producir ese estímulo, se hace el registro de la persona para tener un input, por ejemplo, su voz, o por ejemplo, graban sus expresiones faciales o le hacen algunas preguntas para tener información de texto. Y el más popular de todos es natural, básicamente grabado de personas en estado natural, en redes sociales, por ejemplo, comentarios reales de personas, espontáneos. Que tiene de bueno, pues que no es actuado, tiene, digamos, que todos esos componentes de naturalidad en los datos, son muy abundantes. Lo malo es que normalmente son muy desbalanceados, ¿no? No vas a tener tus categorías, vas a tener mucho más muestras de ciertas emociones o ciertas polaridades respecto a otras. Cuando anotamos, pues también es importante hablar de los niveles de granularidad. Aquí hablamos de que si tú tienes un texto, ¿vale? Tú puedes resumir todo el texto con una emoción, o puedes enfocarte en párrafos, o puedes enfocarte en ese punto específico donde está la opinión. O si quieres ser más granular, puedes ir directamente, imagínate un review de Amazon, puedes ir directamente a esa característica de ese producto y ver las emociones que están hablando de ese token en particular, ¿no? Entonces hay distintos grados de granularidad como se hacen estas anotaciones. Eso es importante porque no solo cuando trabajas con texto, cuando trabajas con sistema multimodal, en el que tienes diferentes fuentes de datos, tienes que alinear video con audio y con palabras, entonces aquí es muy importante definir ese tipo de características. Respecto a los tipos de anotación que se usan, pues hay 3 enfoques principales. El primero es el categórico, en el que tenemos, digamos que la emoción pura y dura, sin ningún tipo de ponderación numérica, una categoría como enfadado, como alegre, y ya está. Digamos que no hay un orden aquí específico, simplemente es una categoría. Tenemos el dimensional, en donde lo que se trata de hacer es un modelo en 2 o 3 dimensiones para poder medir la intensidad de esa emoción, qué tan placentera o positiva o negativa es, y el nivel de control que tiene esa persona sobre esa emoción, que son básicamente los 3 ejes que se miden. Y tenemos el componential, que básicamente es una mezcla de los dos, ¿no? Trata de asignar categorías y números. Si vemos esta clasificación, pues son los 3 enfoques principales que se usan en análisis de sentimientos. El que les muestro en la figura 5 es el enfoque del doctor Ekman, que está muy popular por la serie Lie to Me, donde empezó a investigar las emociones al nivel facial. Es un esquema de 6 emociones, uno de los más populares y más extendidos. Tenemos el esquema de Plutchik, que es básicamente un esquema de 8 emociones, y lo que se busca es sobre esas 8 emociones entender con diferentes niveles de intensidad en el eje vertical y las combinaciones de esas emociones que producen otros, por ejemplo, joy, trust y producen love, ¿no? Abajo tenemos el esquema que comenté, el esquema de 3 dimensiones de Dominance, Arousal y Balance, que busca medir la energía de esa emoción. Arousal, Balance, qué tan positiva o negativa es, y el Dominance, que se refiere al nivel de control que tenemos sobre dicha emoción. ¿Qué sucede? Que esos dominios normalmente se puede ir de un dominio a otro, ¿no? De un dominio de categorías de 2 dimensiones a uno categórico, o de uno de 3 dimensiones a 2 dimensiones. Se suele hacer ese tipo de migraciones, ¿no? ¿Cómo? Algunas veces se enfoca como un problema de optimización en el que se busca distribuir de manera uniforme unas categorías dentro de otras, o con modelos de aprendizaje automático, en lo que se busca aprender esa categoría, dados unos valores numéricos, en el caso del modelo de 3 dimensiones de Dominance, Balance y Arousal. Aquí pues se puede ver que cuando se hace ese mapeo, pues realmente en general puede haber una pérdida de sensibilidad, como en el caso del modelo de 6 emociones de Ekman, que son los más populares, pero realmente cubre un espectro de emociones positivas muy, muy grandes, y ese es uno de los, como vamos a ver más adelante, uno de los aspectos más negativos de este tipo de caracterización. Otro tipo de taxonomía muy popular, pues consiste en básicamente simplificar los estados de emociones a básicamente polaridades, como puede ser positivo o negativo, o positivo, negativo y neutral, o positivo, negativo y ambiguo, que son como los 3 enfoques más populares que existen. Cuando se analizan los tipos de anotaciones, pues se han hecho investigaciones desde 3 puntos de vista. El primero, que es el que vemos en la figura 9, se ha analizado las personas que hacen las anotaciones, las personas que dicen este texto qué emoción tiene, o ese texto qué polaridad tiene, cuál es el agreement entre ellos. Imagínense que cogen 5 personas, les pasan un dataset con varios textos, ellos tienen que evaluar cada uno de estos. Entonces miren el nivel de agreement, qué tan alineados están ellos en esa evaluación de esos textos. Pues lo que han concluido finalmente es que los niveles con menor cantidad de categorías son los niveles que tienen más agreement entre todos ellos. Y los niveles más granulares, como texto libre o el modelo de WordNet, que es un modelo con muchísimas categorías, pues son los que tienen menor agreement, como se suele esperar, ¿no? Desde un punto de vista del anotador, ¿qué tan fácil es anotarlo? Pues muchos comentaban que es muy fácil utilizar categorías de texto libre, porque básicamente tú no tienes que pensar en una categoría, sino asignas lo que tienes en tu mente, pero a largo plazo, pues se vuelve una tarea tediosa porque muchas veces no encuentran la palabra para describir esa emoción. Entonces, se vuelve más práctico utilizar un modelo poco granular como el modelo de 6 emociones de Ekman. Termina siendo, digamos, que un ejercicio mucho más rápido y práctico para realizar ese tipo de anotaciones. ¿Qué problemas tienes? Pues tienes una pérdida de granularidad, evidentemente. Dependiendo del dominio de aplicación o lo que quieras hacer en negocio, pues puede que estas 6 emociones no te den la granularidad que necesitas para responder esas preguntas importantes. Desde el tercer punto, como se ha analizado, es del punto de vista de los modelos de aprendizaje automático. desde el punto de aprendizaje automático, pues tenemos un análisis en el que se ha enfocado en ver el performance de los modelos desde el punto de vista de las métricas precision y recall. Son las métricas que normalmente se usan para evaluar datasets que no son muy balanceados, tienen más cantidad de datos de unas categorías que otras, y pues es lo esperado, ¿no? Los modelos de menor granularidad, como las 6 emociones de Ekman, tienen un rendimiento mucho más alto que las otras categorías que tienen mucho mayor granularidad. Respecto a los tipos de tareas que se suelen realizar en análisis de sentimientos, pues las más populares están relacionadas con detección de eventos, de eventos de esas emociones. Se ha utilizado en muchos trabajos para detectar en redes sociales, por ejemplo, para poder evaluar para poder evaluar cómo reaccionar ante catástrofes como terremotos, por ejemplo, para ver dónde están las personas hablando, qué emociones están generando y poder poner alarmas. Es una aplicación muy, muy popular que se ha estado implementando con EPAM Análisis. Otras más que tenemos son Stance Análisis y Affect Análisis, que están relacionadas con la clasificación de emociones y ver si una opinión está alineada con una postura. Entonces hay determinada postura que dice esto es así y quieren ver si las opiniones de las personas están alineadas con esto o no. Y las dos más populares pues son el análisis de polaridad, que como vimos es básicamente determinar si una opinión es positiva, negativa, neutral o ambigua, y el Aspect Back Sentiment Analysis, que es una de las aplicaciones más comerciales utilizadas, que consiste en analizar al mismo tiempo emociones, polaridades y entidades. Entidades, estamos hablando de productos, servicios o características de productos, como por ejemplo puede ser el caso de Amazon, el móvil, podemos hablar de la batería, podemos hablar positivamente de la negativa de la batería, y podemos hablar de manera negativa del teclado, etcétera, ¿no? Esas son opiniones comparativas. Cuando tienes varias en la misma opinión, las regulares son las simples, hablas de una sola cosa. Otras tareas que también se suelen identificar, que se suelen realizar, pues son más relacionadas para identificar quién es el que hace la opinión y sobre quién se opina, básicamente. Aquí unos ejemplos de dominios de aplicaciones en e-commerce, donde se analizan impresoras, se combinan impresoras de varios proveedores, y básicamente se analizan ciertas características asociadas a ciertos niveles de polaridad, ¿no? Esto es un caso clásico de Aspect Based Sentiment Analysis. Otro de los casos es el que les comentaba, el de ver análisis para hacer un poco un análisis de cómo cambian esas emociones en el tiempo. Respecto a los benchmark que he realizado, pues hay bastantes, no enfocados principalmente en ruido. De esto la bibliografía que hay es muy, muy poco, pero sí hay bastante en temas de los resultados que se obtienen, de pasar de unos dominios de emociones a otros. Aquí tenemos un ejemplo en el que empezamos con un nivel de 18 emociones, ¿vale? Es un paper muy famoso que hicieron Google junto a Amazon. El dataset se llama Go Emotions, el año pasado, y básicamente se hicieron varios experimentos con modelos, BERT, para ver la sensibilidad y el cambio de los modelos y la estabilidad de los modelos cuando se disminuye la granularidad. Aquí se ha disminuido el modelo de 6 emociones de Ekman, el performance aumentó hasta 64%, y una vez que se reduce aún más la granularidad, simplemente positivo, negativo, neutral, ambiguo, pues aumenta casi un 5% más el score, ¿no? Que es, digamos, que lo esperado. Entre más reduce la granularidad, pues digamos que esa ambigüedad que tienes al nivel granular es reducida. Entonces, es una de las características, digamos, más comunes en las que se lidia con el bajo performance en estos modelos. Las consecuencias que tienes, por supuesto, si disminuye la granularidad, quizás ya el SEO pues, no sea el adecuado para la respuesta que necesitas responder en negocio. ¿Okay? Vale. Si nos referimos a los tipos de ruido, pues hablamos de que típicamente tenemos ruido en los atributos y en la clase. Si nos enfocamos en texto, pues el ruido que podemos tener en el texto es el típico. Si estás analizando, por ejemplo, redes sociales, pues vas a tener, debido a la espontaneidad con las que hablan las personas, pues vas a tener errores ortográficos, por ejemplo, mucha presencia de emoticones, abreviaciones o palabras que usan ciertos grupos de personas muy particulares. Cuando nos enfocamos en la clase, pues ya ya estamos hablando de que la anotación que se le ha dado, la emoción que se le ha dado a ese ejemplo, pues no es la adecuada, ¿no? Si nos enfocamos en las causas de esos errores, pues hay varias. La primera es que cuando las personas no tienen claro el criterio de anotación, Esto sucede mucho, sobre todo en el sector empresarial, cuando los requisitos no están muy claros. Pero en la parte de análisis de sentimientos, el que más sucede es que básicamente la clasificación es muy subjetiva y lo que una persona puede percibir como una emoción o con un nivel de polaridad determinado, otra persona lo puede ver ligeramente distinto. Los otros dos que aparecen aquí son cuando se asignan se ponen anotadores que no son expertos en esa tarea en especial. Y por último, y no menos importante, son los típicos errores humanos que se producen en los errores de notación, que la persona hace clic de manera errónea o se equivoca digamos, en la logística de la introducción de esas categorías, no en la forma en cómo interpreta las categorías. Para analizar los tipos de modelo que tenemos, pues tenemos tres tipos de modelos principales. Con X nos referimos a los features, Y se refiere a los labels, al error, Y a la etiqueta asignada a ese label por el anotador, ¿no? El primer modelo, pues es un modelo label not completely at random, que se refiere a un modelo en que el error no depende ni de los features ni de los labels. Básicamente un error que está distribuido en todo nuestro dataset de manera uniforme, no dependemos de nada aquí. Tenemos el modelo B, que el modelo B, el error, depende básicamente de la categoría. Esto es algo que sucede mucho en análisis de sentimientos, porque generalmente cuando los anotadores no saben qué categoría asignar, tienden a asignar una categoría mayoritaria. Por ejemplo, el tema de polaridad, si no están muy seguros que es positivo o negativo, tienden a poner neutro. O en el modelo de 6 emociones de Ekman, pues tienden a poner bastante la categoría mayoritaria, que es positivo, ¿no? Que es happy, ¿vale? Tenemos por último un modelo, el tercer modelo, que es Label Noise Not at Random, que depende tanto de los features como de los labels, y pues esto llega a suceder sobre todo en redes sociales o en contextos donde hay mucha espontaneidad en la forma en cómo se extraen esos features. Respecto a las consecuencias de los modelos, pues bueno, es lo típico. Básicamente, los modelos son más difíciles de interpretar porque se vuelven más complejos. Si ponemos, por ejemplo, como por ejemplo, árboles de decisión, el tiempo de ejecución es mucho más lentos. Si nos enfocamos en las dos principales enfoques que existen para enfrentar ruido, pues el primero son los filtros. Los filtros lo que se encargan es de asignar a los diferentes ejemplos que tienes una etiqueta para decidir si es ruido o no, y lo excluyes o lo incluyes en tu dataset de entrenamiento. Y el primero son modelos que por sus características tienden a ser robustos al ruido. El segundo, como vamos a ver más adelante, pues tiene un performance que es muy bajo. Generalmente funciona muy bien con modelos de ruido que están distribuidos de manera uniforme, que no es el caso de las análisis de sentimientos. Aquí tenemos, por ejemplo, un performance de una librería muy famosa llamada CleanLab, que se encarga de aplicar estos enfoques de filtros, y el rendimiento pues es muy similar al que podrías tener con una estación de características TF-IDF y una revisión logística, ¿no? Realmente no ayudan mucho a mejorar el performance. Ya si te enfocas un poco más en los modelos que son robustos al ruido, pues se han analizado mucho los modelos BERT porque han mostrado, digamos, una mejora en el estado del arte. Si analizamos la barra verde, pues es sin ningún tipo de ruido, básicamente el mejor rendimiento, pero con ausencia de ruido, pues si analizamos el delta entre los scores con ruido y el mejor performance, pues es el que tiene la mayor caída, por decirlo así. Vemos que prácticamente modelos simples con un TF-IDF, con Naive Bayes o un Logistic Regression, pues tienen resultados comparables. Aquí quien ha destacado son unos algoritmos de autómatas llamados Tesla Machines, que básicamente funcionan como una especie de máquinas de estados con cláusulas, que funcionan como una especie de agente que define ciertos estados, construye features binarios. Para darles un ejemplo, contexto, dicen si esta palabra está y esta no está, eso es un feature. Otro feature puede ser si estas tres palabras o este enegram sucede y esto no sucede, bla, bla, bla. Y al final hay una capa superior que construye una lógica con todos esos features para construir un clasificador y decidir si está o no está la emoción. Básicamente es como funciona un poco a alto nivel. Y estos modelos pues han mostrado en texto el mejor rendimiento. ¿Qué sucede? Pues si vas a trabajar con modelos multimodal, en los que quizás vas a analizar componentes de señal de voz o señales de video, pues posiblemente estos algoritmos quedan fuera del alcance para realizar ese tipo de implementaciones. Por último, quería compartir algunas fuentes, ¿vale? De proyectos relacionados y fuentes, proyectos relacionados para el filtrado de ruido y análisis de emociones en general. Y ya está, es todo lo que quería compartir, hoy.
Muchas gracias. Quiero pedir a Antonio que me ayude porque ya no quiero sorprender a la gente con mi español más.
Claro. Bueno, pues había algunas preguntas también que tenemos por aquí. Y bueno, una de ellas era si, por ejemplo, puede detectar el sarcasmo.
Actualmente son uno de los retos que hay en análisis de sentimiento, ¿no? Hay muchos trabajos que se han enfocado en hacer esa detección de sarcasmo, pero digamos que los modelos que tenemos ahora tienen un performance muy bajo. Es uno de los retos que tenemos actualmente en análisis de sentimiento. Digamos que la detección de sarcasmo es uno de los retos que son tema de investigación abierto en la actualidad, debido a la complejidad, del problema, ¿no? Es difícil hasta para un humano hacerlo, y para una máquina también lo es, ¿no? Entonces, es un tema de investigación abierto, pero realmente no hay como modelos con un performance muy destacable para decir es un problema que tenemos bajo control. Es más bien una línea de investigación abierta.
Oh, ok. También otra pregunta es si funciona con todos los idiomas.
Pues digamos que las dos técnicas, bueno, las de filtros, ya comenté que no funcionan muy bien, ¿no? Funcionan muy bien, por ejemplo, con temas de imágenes, en donde tienes un ruido uniforme distribuido, no específicamente para una clase, porque esa emoción es diferente de clasificar. Básicamente no se han hecho estudios multidioma para hacer un diferente performance, pero en temas generales, digamos que estas características de ruido son independientes del idioma. O sea, realmente los retos que tienes tú para tanto clasificar como para definir las anotaciones son totalmente independientes del idioma, porque el grado de subjetividad es por la emoción,
Claro.
¿no? Es por la fuente de datos, no por el idioma. Entonces, las técnicas que se implementan, los modelos que funcionan bien, pues funcionan bien es independiente del idioma. Es una variable que no, digamos, consideramos allí.
Vale, y por último, otra muy interesante también que dice que actualmente en la psicología una línea de pensamiento es que no existen las emociones positivas o negativas, ¿no? Y la pregunta es que si piensas que, bueno, pues dentro de un futuro próximo, el análisis de qué sentimientos, pues, o bien dejará de existir o se considerará que es algo no ético.
Bueno, pues la primera parte respecto a definir que una taxonomía es mejor que otra, es un debate abierto, ¿vale? Eso no hay una verdad. Digamos que hay varias líneas en este momento, la de Plotnik y Ekman, son como las dos más grandes, ¿no? Las dos taxonomías más fuertes, y los dos son proyectos enormes que tienen detrás financiación de gobiernos y entidades. Digamos que son una rama de la psicología en la que no hay argumentos para poder decir que una es mejor que otra y rechazarlo. Entonces, digamos que, como he comentado, pues vendría siendo es algo que está abierto. Y respecto a lo que comentas de si es algo que se va a dejar de usar, yo creo que es lo contrario. O sea, realmente hay un crecimiento a tratar de implementar nuevos casos de uso para este tipo de aplicaciones. El ejemplo que les comenté al principio es una aplicación en la que estaba trabajando precisamente en la detección de estrés, en la que hemos trabajado con señales de voz y texto para hacerlo, porque básicamente tenemos una alta disponibilidad de datos. Ahora, eso es lo bueno, ¿no? Pero ahora lo que tenemos en contra son básicamente las leyes de protección de datos, ¿no? En la que no es tan fácil tú llegar y usar datos biométricos de las personas, porque básicamente si tú estás utilizando la voz, estás utilizando la cara, estás utilizando esos datos biométricos y tienes que tener los permisos de esas personas. Anonimizar este tipo de datos es muy complicado, es muy complicado. Hay técnicas de normalización, pero eso es más a nivel del modelo, no a nivel de no identificar a esa persona. Entonces, digamos que las reglas, al nivel de leyes, pues las restricciones están aumentando, está volviendo mucho más retador, Pero por otro lado, si nos centramos en el poder de cómputo, en la disponibilidad de datos, pues es mucho más fácil hacer eso ahora que antes, ¿no? Entonces ahí es un,
Sí.
no es blanco ni negro, es gris.
De acuerdo, pues muchas gracias, Jonathan.
A ti.
And I think we can switch back to English if you prefer, Kseniia.
Yeah, thanks guys. Thank you, Jonathan and Antonio. And thanks everybody for watching us, for asking your questions. Tomorrow at the same time, we are going to have 2 more tech talks about automation of KPIs via Power BI and pair programming. So come to us, join us, and see you. Have a nice evening.
See you tomorrow. Bye bye.
Okay.
Thank you.
Bye.
See you tomorrow. Bye.